Okay, welcome to the webinar for false targets during ground testing, cause and prevention. And this has become a common problem. So we thought we would put this presentation on. And the objective tonight is to hopefully reduce the amount of false targets that occur. Appreciate everybody logging in and attending. My name is Gary Mitchum. I'm the FAST Team Program Manager at San Antonio for the airworthiness aspect of it. We also have Ryan Newman, who's the FAST Team Program Manager for Operations at San Antonio. We also have some folks from the Aircraft Maintenance Division, AFS 300 group. We have Marcus LeBay, Charlie Fellows, Jerry Crowley, and we have Brent Elliott from the ADSB Focus team. He's the team lead. And we also have Carrie Crawford, who's the product manager for Viavi Solutions, manufacturer of avionics test equipment. First question is, why do false targets occur? And when we conduct transponder testing and we simulate altitude, this sometimes presents a false target in the national airspace. It's been an issue since the introduction of TCAS. And the reason is the airborne TCAS unit is interrogating other transponders. This includes units that are under test. And if the unit under test responds to that interrogation, creates a false target. This slide represents some ghost targets or false targets. And this can generate TCAS resolution advisories for TCAS 2 systems. And this can be hazardous. Some of the warnings that they will get, some resolutions advisories are climb, descend, level off, etc. And pilots have to respond to these resolution advisories. They're required to respond to them. One of the problems is if you have a lot of false targets, it's the law of unintended consequences. Pilots can effectively turn off the resolutions advisory mode. So if they go to TA mode, they'll just get traffic advisories. They won't get the RAs. Although they're expected to keep the system in the TA-RA mode. There was a study that was done that found that too many false targets can result in pilots deselecting that mode. Now that there's been more advancements in technology, these false targets are visible to more entities, not just airborne TCAS units. We now have ADSB ground stations all over the country. Later on, we'll see a map of how many are just around the San Antonio FSDO. These ADSB ground stations can detect RF leakage from a unit under test and rebroadcast that. And these rebroadcasts will be picked up by aircraft that have ADSB in systems. So here's a slide that depicts an airborne ADSB in system on the right side. And there's three sources of traffic that will be displayed. The top one is considered direct link or common link. It's an aircraft that has ADSB out and it's transmitting on 1090 megahertz. The middle aircraft is considered alternate link. It's an ADSB out system that's on the UAT frequency of 978 megahertz. And the ground station rebroadcasts that at 1090 megahertz. And this will be displayed by that airborne ADSB in system. The bottom aircraft does not have ADSB, just transponder. And its response will be rebroadcast in the 1090 and UAT format as TISB information. So the point of the slide is the rebroadcast. If you have a unit under test and it picks that up, it's also going to be rebroadcast. And aircraft with ADSB in are going to see that traffic. Now, these false targets are fed into numerous data streams that are monitored and displayed by air traffic control systems. And I'd like to have Charlie Fellows from the Aircraft Maintenance Division discuss those numerous data streams. Charlie, you there?
Yeah, can you hear me now?
Yes.
Okay, good. Well, yeah, I guess the best explanation is to compare this back in time, back in the, I guess it was the late 50s or so when radars started to pop up. The vision that we all had was of a controller looking at a repeater display in the tower or someplace like that. And the display was linked directly to an on-field radar, just a pretty direct connection. As time went on, more repeaters and such showed up and such. But if you fast forward to today, air traffic controllers aren't looking at a repeater display radar. What they're looking at is a composite of traffic information. As we saw in the previous slide, this traffic information can be made up from ADSB returns, from radar returns, and different sources. And in fact, when the controller is looking at their presentation, I'll call it their radar presentation, but really what it is a traditional traf video presentation. When they're looking at that, the airplane they see may be being interrogated by 3, 5 different radars. What they're seeing is the radar position information and such is a composite of the system processing that and giving them a icon or a display. Also in there is ADSB traffic information, which the controllers have the ability to either turn on or turn off to augment the basic aircraft position information they have. So the bottom line is that now, while maybe back in the early days, if you were radiating a signal, free ramp testing with no couplers or such, you had to worry about interfering with an airplane that was flying over you that just had the right position to where you were giving them a false TCAS alert or something like that. And possibly if you were close enough to a radar site, tower controlled airport or something like that, you might show up on their display. But nowadays, if you're being picked up by the ADSB receiver site, you're in the national composite traffic picture. And so anybody looking at that will see that target. And also, it's a very good indication if you're being picked up by the ADSB site, you probably have enough leakage and such that you're going to pick up an airplane flying over you with a TCAS doing their inquiry and respond to that. So it's a much bigger problem, and it's going to get to be worse because right now we are painting our picture of ADSB traffic by local ground-based monitoring stations. In the future, we're going to go space-based. And I can guarantee you that if you've got a repair station tucked into a little valley that's not being seen by the ADSB ground station, once we go to satellite-based ADSB, you're going to be seen. So it's something for everybody to be concerned with, and just plain and simple, you're radiating false position information. No good's going to come of it for anybody. So follow the proper procedures in the manufacturer and the test equipment manufacturer's recommendations and avoid radiating that HMI. I guess that's about it.
Thank you, Charlie. So now the air traffic system and what everybody is seeing is not only TCAS, but it's ADSB, it's all these multiple data streams, and it's a composite. So the problem is much worse than it used to be. So as a result, just contacting the tower when you're going to do a test is not effective anymore. And I'd like Marcus LeBay to discuss these next number of slides up through 15, if you would, Marcus.
Sure, thank you very much. You brought it out very clearly. The legacy mitigation of contacting ATC is no longer effective, and as Charlie illustrated, if you contact ATC, the folks in the tower or ATC will know about it, but that provides very little benefit to the surrounding aircraft that may have ADSB in or be TCAS equipped. And in fact, we've had several ATC, since we started this notification process, we found out there's been several ATC facilities that are turning down the calls to the tower and saying, hey, we're going to do some testing for several reasons. I think liability is one of them, because they know that there's other more robust mitigation means being the proper test equipment that you can use with the couplers and different equipment. Next. We've had several safety databases that show one very good one is the NASA ARSA database, and you can go into that database and search for TCAS ghost, TCAS false alerts, and you'll see quite a few of them are in there. And while some can be explained as actual targets, but there's quite a few that are in that database that are still attributed to unknown targets in the area. And I know of two of them that were identified as testing going on an airfield. And when you look at take a little bit further, you look at the SAFO that was published in 2017 by the ADSB team. There were several cases that were they did know exactly where the repair stations were. And so there's a lot of evidence out there that this has been an issue for quite a while. Next. And there we go. The SAFO 17002. I kind of touched on it, and we'll get to it a little bit later. The SAFO is in revision right now. Some of you are probably looking at it and going, well, it tells us right here to contact ATC. We are going, that is in revision. It's in internal FAA review. And the big part of that revision is we are taking out the ATC notification, because unfortunately some folks were reading it as contact ATC or use test equipment when it was really intended to be contact ATC and use test equipment. Next. With the ADSB tool about a year ago, or actually a little bit longer, it was probably January of 2020. This started with several events. We had, of course, the false events that generated SAFO 17002, and then several of us are on an RBSM working team where the RBS team out of the Atlantic City Tech Center were letting us know that they were seeing aircraft at RBSM altitudes that were not really there. So they created a database, basically a tool that looks at these aircraft, at every aircraft, and they have some parameters built into their software to where they'll see an aircraft that had none or very little lat long movement, but a significant increase in vertical in altitude, and then they classify the aircraft, and you'll see a snapshot of these reports later. But at the end, after midnight, this report is generated, and then we pick it up the next morning and we look at what all happened the day before. Next, please.
Okay, one thing I would like to mention for the audience, if you have questions, you can type in your question. And I forgot to mention this earlier. And at the end of the presentation, we will address and answer your questions.
This is some of the data that comes out of the ADSB transmissions, and you will notice we see all these on the report as far as the aircraft's location, its altitude, and type of aircraft and equipment that's installed on the aircraft. And with that information, after a year of this, we can pretty much look at an individual report and tell whether it was a test or not. Some of these aircraft, like I mentioned before, the report looks at the velocity of the aircraft and the lat long. We've seen several of these that are not actual tests, the airplanes in flight, but it's either doing, we've got several aircraft that we see on the report frequently that are out doing acrobatics, so they're not moving much in a lat long area. And then we also have aircraft that may be crossing a mountain range and hit a headwind, and they'll also show up as a test. But when we look at the graphic, we can tell with the information like you see here, we will look at that aircraft and we can tell that it's not a test either. Next. Okay, the ADSB performance monitor. I tell you, I would like to pass this over to Brent Elliott because this is his area of expertise, and then I can pick up after this one. Brent.
Okay, hello everybody. This is Brent Elliott. I will go through the slide here and elaborate as necessary, but so many areas of ADSB, especially ADSB out, it's easy to go down rabbit holes, so I'm going to do the best I can to avoid that. So with the data that's in front of us, so we have non-equipped operations in ADSB rural airspace, and those that are improperly equipped that may have the wrong version and link and things like that. So the APM really at a higher level is a web-based application suite that tells us all kinds of different things about all of the aircraft that are equipped in the NAS and how those avionics systems installed in those aircraft are performing. As you can see in the last bullet, 91.227, that's the key regulation for ADSB out avionics performance. And 91.225 is the rule that says if you fly in this area, this is what you got to have. Very similar to 91.215. Since I think everybody on the webinar is we all speak transponder pretty well, so I would assume everybody's gotten familiar with those two regulations. If you haven't, please do so. But the APM is the tool that we use to monitor performance on a daily basis. And so just a real quick brief plug on my team, the ADSB focus team, and AFS 360 and 370. That's what we do mainly, is monitor and contact and let stakeholders out there know, particularly aircraft owners and operators, that, hey, you've got a problem with your ADSB. But there's other things we notice as well that are mentioned in here. Aircraft that are flying that don't have the correct version, that don't meet the minimum operating performance standards that are linked by reference in the regulation of 91227. There's all kinds of different nuances of issues that we find in aircraft that have non-performing equipment, NPE. I think everybody's probably heard that term. So our team is kind of the team that uses the APM and makes those notifications. Initially, I was the guy that got stuck with doing, I call it an improper ground test when Jim Marks and myself wrote the SAFO 17002 back in 2017. But the job became more than a full-time job, even for a couple people. So I've talked with probably quite a few of you on some level at some point. But graciously, Marcus and Charlie and Jerry and some of the other my colleagues in the Office of Safety Standards have stepped in to help us get the word out about the ramp test procedures that are causing these false targets. So I think in essence I covered everything there. Gary, is there or Marcus, is there other information that you want me to include in there on this? And if anybody has any questions at all, put them in the chat box and we'll answer them at the end, probably in the order. Gary, I mean, that's of course, that's up to you. But if you have any questions on what we do as well, I'm all for that. We're here to help with that. So that's really all I have on that. Is there another slide, Marcus, that you want me to elaborate on?
I think that was the one. I think that was the one that was a lot of inside your wheelhouse there.
Right.
I can pick up from here.
Okay. Let me add one more thing, Marcus, if I may.
Sure.
Our team deals with installation policy and things like that, and I try to market not my own email address in the FAA, but we have the ADSB focus team at FAA.gov email address, and that's open to anybody out there that has anything to ask at all on ADSB out avionics issues. So that again, if you want to copy this down, is ADSB FOCUSTEAM at FAA.gov. ADSB focus team all together. And I personally watch that email inbox, and I do my best to respond to the inquiries and questions on all different kinds of ADSB subject matter. I respond as often as or as frequently. Excuse me, I'm not saying that right. In a timely manner as to the best of my ability. So thanks, Marcus. That's all I want to add.
Thanks, Brent. Appreciate it.
Thanks. Going to the next slide, the ADSB ramp test report is what we call it. It's an Excel format that is provided by the APM. It shows all the data, like I mentioned before, the aircraft and the date, the time, the altitudes, the registration, the ICAO hex code. So we've got pretty good information that's spit out on that report. And then from there, and this is what I refer to as a good ramp test day. You notice there's only 3 of those there. I did identify the aircraft so you can't tell who they belong to, but basically it gives you, it assigns it an operation ID, and that is each time an aircraft is flown or it is powered up on the ground and it is seen by the monitor, it creates an operation ID. So you can have an aircraft on the ground that you're doing testing for 10 minutes, you power it up, you do your test, you turn it off. That's an operation ID. And you can have another aircraft that leaves the West Coast and flies to the East Coast, and that's one operation ID. It just looks at it from power cycle to power cycle. And that's important if you're one of the entities, and we work with quite a few, we will work with you if you think you have a configuration issue. And I'm kind of bringing this up now, that if you want to do a test and see if your testing configuration is a good configuration where you're not transmitting HMI, you can get hold of us. But the key thing is to remember if you power an aircraft up and you're doing a configuration test and you decide you want to change configuration, you need to power the aircraft down and end that operation ID and then start on a new one, and you can keep track of what you're doing, your configurations and your times. So if we can work with you and we can point out, you know, we saw your first two, but we didn't see your last one. So whatever configuration you used in your last, you were good to go. And so this here is a good ramp test day. You're looking at 4 aircraft. We still average nowadays. We're looking at about maybe 8 to 10 a day. And we can probably throw half of those out. And I'll give you an example. The one there in the middle, that's a UAT, just for everything that I know, actually the top 2. I can tell you the Kid Fox, and then the other one that doesn't have an identification, but it's a UAT system. Both of those were aircraft that were in flight. And I can tell you, because you look at the altitude, there's not much altitude change. And then you look at Salt Lake and Denver, and both of those are mountain ranges, and both those aircraft were probably flying over a mountain range, and their ground track speed decreased significantly. But the bottom one definitely was a test. I'll go to the next one, and I'll show you what a bad ramp test day looks like. That's a bad ramp test day. And you can see that it's a variety of different aircraft and different altitudes and different locations. So we treat each one of these events as its own event. We look at each one. We make sure that it actually was a test. We locate where it is on the map, because the report will give us a Google Earth once we get the test ID, and then we go back and we look and figure out who's operating the aircraft, and then what FAA Safety Assurance Oversight Office is in the area. All right, Gary, back to you.
All right, thanks, Marcus, appreciate it. And I just want to reiterate that your team will help a repair station or an agency if they're having problems determining what is causing the false target. You will work with them, and they can change the configuration and try it again and see if you're picking them up or not.
That is correct.
Okay, thanks. So once they detect a ground test false target, they will send you out an email, and usually it comes from Marcus or Charlie, sometimes from Jerry, or could come from Brent. And they basically tell you that the aircraft was observed at varying altitudes at a stationary latitude and longitude. And once the principal inspector receives this email, they contact the aircraft operator, if it's a 135 or if it's a 91 owner. They try to track down, you know, who's responsible for the maintenance on the aircraft. And in case you're wondering, HMI means hazardously misleading information. When you click on the attachment, this is what you'll see. You'll see the red dots. I believe those are all different altitudes, and you notice it's kind of staying in the same spot.
Gary, I'd like to make a comment on that slide with the graphics.
Sure.
This was early on when we had, back almost a year ago, we were seeing these, and we were still figuring out what we were looking at. The image on the left is an aircraft that is in a hangar with the door closed, but it has a GPS repeater. So you'll notice that the cluster of the reports are really tight. The aircraft on the right is also in a hangar with the doors closed without a GPS receiver. So the aircraft's location is, you can see it's almost like a shotgun blast, where it's just all over the place because it doesn't know where it's at. And in both of these images, you'll see the pink pin. The one on the left has a pink pin to the northwest, and then the one on the right has one to the northeast. The pink pins you'll see later on in Gary's presentation, these represent an ADSB ground receiver. And I can tell you that both of these locations, working with us and the test set manufacturers, these locations are no longer seen, even though they're less than a quarter mile from an ADSB receiver. All right, back to you.
Okay, so you're saying that they were able to resolve the issue and develop procedures and, you know, where they don't have this problem anymore?
That is correct. And I think Carrie's going to cover that from Viavi.
Okay, yes, and you can see those are very close to the ADSB ground station. So when the principal inspector gets the email, we notify the director of maintenance or the repair station manager. We'll provide them with this location. We like to provide the time of day because that helps them determine what technicians were doing the work, what test was being accomplished, so on and so forth. We also include a copy of the SAFO, and we'll ask the DOM or the repair station manager to do an investigation, try to determine the type of test that was being conducted, type of equipment that was being used. Were the attenuators or the blankets, the RF blankets being used? Was it inside or outside a hangar? But as you can see, as Marcus said, even inside a hangar, it seems like it might be helpful, but it doesn't solve the problem. We asked them if the technicians that were doing the work were trained, and we also asked them to look at the technical data that was being used to make sure that it was adequate. Now, as a result of the investigation, sometimes it requires a facility to obtain proper equipment. Sometimes they've got to train technicians on how to operate the equipment, how to configure the aircraft, so forth. Sometimes they find that their training program is not adequate, so they may have to revise their training program. Maybe they haven't trained the technicians on this new piece of test equipment that they've acquired. If they do find that the technical data is incomplete or not adequate, we ask them to submit publications, change requests to the manufacturer. And sometimes they just have to develop better internal procedures. So some of the solutions that have been developed are covered in the next slides, and I'm going to ask Carrie Crawford to discuss these next slides. Carrie Crawford. Let me make sure I don't have you muted. There you go.
All right, thanks, Gary. Yeah, this is Carrie Crawford with Viavi Solutions. I'm the product manager for our flight line test solutions. Some time back, actually it's quite a few years ago, we were asked to develop some RF blocks or antenna couplers for our test equipment. And that was a result of some testing that was being done on the ground. And then that RF transmission would be picked up by TCAS equipped aircraft. And as a result of being picked up by the TCAS equipped aircraft, that TCAS would then interrogate the aircraft being tested on the ground, would respond, and you would have a traffic advisory pop up, as you know. So a little history on that. So we developed our couplers, and they have about a 25 dB attenuation. So when using the couplers in that scenario, even if there is some RF leakage, the TCAS equipped aircraft may still pick it up if it's very close by, but just the fact that you now have an RF coupler attenuating that signal or blocking the antenna, the aircraft on the ground being tested would never see the interrogation from the TCAS, so then it would then ignore that interrogation. So one thing I want to make note on this slide here, it mentions it the antenna couplers will block the airborne TCAS interrogation from getting to the UUT. We will reduce the RF leakage that's coming out of the aircraft because there will be some RF leakage. And I'll speak to that just a little bit more. So can we move on to the next bullet here? So in addition to our RF couplers, what we have discovered, I'll get into this a little bit more in another slide, is that since there is RF leakage, you may need to have additional attenuation either by testing indoors using your hanger or using some RF fabric or RF type blankets. So the next slide, please. So here's some examples of the antenna couplers that we currently have available. The square antenna couplers is what we call our UC584S and UC584s. Those are for the shark fin L-band type antennas. And they actually work fairly well. They provide typically more than 25 dB of attenuation. The larger coupler you see there is for the combined TCAS and transponder type antennas like the Rockwell Collins TSS 4100 or the ACSS 18910, for example. The OEMs are getting smart on us and combining their antennas for both TCAS and transponder signals. And that specific coupler also has a bearing selector switch on the top. So since that is the type of antenna, you need to test all the different quadrants of that antenna. It's not a it's not an omni type antenna. All right, so let's frame it up. Go to the next slide, please. So a typical 250 watt transponder has about 54 dB of ERP, effective radiated power. And to frame that up, an unshielded antenna can reach out about 107 miles. So that's quite a ways. Let's go to the next slide, please. So using our antenna couplers, a typical 250 watt antenna provides about 25 dBm of attenuation. And as you can see, that reduces your radiated power out or shields it to where you could have still as much as 28 dBm of RF, and you can still reach out 6 miles if there's RF leakage. And again, this is a typical 25 dB of attenuation. So it's very important when you are using an antenna coupler or an RF block that you get a good seal on the aircraft. So you have to have a good fit, make sure there's no gaps on the bottom, and then you should be able to exceed that 25, get up closer to 30, even over 30 dBm of attenuation. We have seen that, which will reduce that down even further. And still you might say, well, 6 miles or even 3 miles, you have an ADSB ground station that's actually, right outside your hangar door. So that's where the RF blanket comes in. When you get into those types of situations, even if you have a good seal, and if you have an ADSB ground station that's right outside your door, you may still have to provide some additional shielding by testing inside the hangar with your door shut, and if necessary, also use some type of an RF blanket. Go to the next slide, please. Some examples of, there's a lot of different RF fabrics out there or RF blankets, and typical RF blanket will provide up to 80 dB of attenuation. There's a lot of different companies out there you can procure these from. We don't sell them ourselves. You can go to Amazon and select them. Edmo distributors, I believe they also sell some RF blanket material and some tape to seal the RF material to the aircraft. And next slide, please. And here's some examples of RF materials that you can get. I believe these are pictures that I pulled off the internet, and I think they might have even been from Amazon. You can see that we had taken some of the RF blanket material and actually sewed the edges up and then fastened some couplers, or not couplers, yes, some suction cups to the corner, so you can easily throw it over the antenna and seal it down pretty well, and it worked fairly well. This specific location where you see that RF blanket with the suction cups on, we had the door open, the hangar door, and we had actual line of sight to an ADSB ground station, which was, I believe, about a little over a quarter mile away. So it was fairly close, and we actually coordinated this test event with the FAA, did some testing without the blanket. We did testing with only a coupler, and we did testing with the coupler and the RF blanket material to prove that it would work. Next slide, please. Here's just some more examples, and these, as you can see, the material is fairly inexpensive. I think for 20-25 bucks you can buy a piece of RF material and some blanket material if you have a situation where the ground station is close to you and you don't believe that you're going to get enough RF attenuation by just using an RF block or an antenna coupler.
All right, thanks, Kerry. Appreciate it.
One other thing I'd like to mention before we move on, I think we've had some fairly good success. Our antenna couplers, unfortunately, are not a one-size-fit-all. We have come across some of the shark fin or blade type of antennas that are just a little bit too thick to slide the coupler onto and get a clamp onto it. So we're well aware of that. We have this in the queue to look at. We just have some other priorities that we're working on now, but we're looking to modify some of our couplers or make some better couplers in the future that will provide some additional attenuation, maybe where we can get to the point where you don't have to have the added blanket material or test indoors. You can still test outdoors. So we are exploring that. Thanks,
Kerry,
Gary.
are the couplers held on just through friction, or what holds them?
Well, we have two separate couplers. We have one that has a clamping mechanism on the side of the coupler, so you slide it onto the shark fin antenna and then clamp it down. And then because of some of our the larger aircraft manufacturers or maintenance facilities, they don't want to go out onto the fuselage, so we have another one that has a hook on the top to where you can set it on the upper antenna just with a placement pole. So it's just held in place through gravity.
Yeah, I'm showing that slide now. You can see the hook attachment point on that one coupler.
Mm-hmm. And we have, we've worked and had many discussions with a lot of shops out there that they continue to get picked up by the ground station and rebroadcast, and many of those have been just not having a proper seal, or they didn't get transponder 2 shut off, or it's been a lot of cases like that. There has been cases where just using the coupler itself, and they do have a good fit and following all the proper procedures. And again, if that ground station is just right outside their door, or they may still get picked up. So that has occurred. And one thing I didn't mention is, what we weren't aware of, and I don't think anybody was aware of what was going to transpire when we got all these ADSB ground stations out there, is they're very sensitive. I believe they have a minus somebody can correct me if I'm wrong, but about a minus 84 dBm of sensitivity. So it's, they're very sensitive. So got to take
So
all precautions you can.
they're more sensitive than the airborne equipment.
That's correct. I think the airborne equipment's minus 74.
All right, thanks, Kerry. So even though we have some solutions now to prevent the false targets, or at least greatly reduce them, we continue to get a lot of these reports, as you saw with the slide that Marcus showed on a bad report day. I don't know, there was probably 40 or 50 events. So some of the possible causes of continued reports are a lack of awareness of the SAFO and the problem. Maybe the test procedures in the aircraft maintenance manual are outdated. And some questions to ask: does the AMM match the test equipment manual? Sometimes the test equipment manual is has provisions to prevent this RF leakage, but the aircraft manufacturer has not updated their manual. And conversely, that maybe the test equipment manual is not up to date. And a lot of equipment has been installed by STC. Every supplemental type certificate has instructions for continued airworthiness that have to be followed. They need to be incorporated into the maintenance of the aircraft. And so another question is, are the ICAs that are part of that STC, are they being followed? Believe it or not, it's really hard to find a picture that depicts defective test equipment. So I found this one. It's a mouse has taken up house in this old piece of equipment. But test equipment could also be the cause, and I'm guessing that in particular the coaxial cabling could be at fault. Kerry, have you encountered test equipment where you could isolate a particular false target problem to a piece of test equipment?
I don't believe I can't say that we have, no.
Mm-hmm.
Well, unless you are referring to a defective coupler, or
Yeah.
yes, you need to make sure that your equipment is in good working order. Yeah, you could have a frayed connector, a frayed RF shield on a piece of coax that you're using with your coupler, from your test set to your coupler. So that would be an example of defective test equipment.
Okay, thank you. Another reason is outdated test equipment. The old ATC 600 is just not going to work for testing these modern systems. Some of the older test equipment, I don't believe, is compatible with the new couplers either. Is that correct, Kerry?
That's correct. If the test equipment doesn't have the ability to enter the loss values from the couplers or from cables, then it likely will not work. If it has the ability to enter the loss, then I don't see why it would not.
Okay. Another reason is the procedures are there, but technicians just fail to follow the procedures. Making an assumption that hanger shielding is good enough to stop the leakage, as we've seen that it might help, but it's not going to stop the leakage from occurring. Using air traffic control contact as your sole mitigation. We do continue to have facilities not use any kind of couplers or procedures, and they just notify air traffic control that they're conducting a test. And as Charlie discussed, with all these multiple data streams showing up on everybody's screen, that's going to put false targets into the system. Another root cause is if you're in close proximity to an ADSB, a ground receiver, it can be very challenging to eliminate false targets. And here is the picture that Marcus provided, and I believe at the center of the spider web there in the middle is San Antonio. And so those are ADSB ground stations. Marcus, are we able to get a really good location, exact location of these stations? Something better than this map is what I'm saying. If we have a repair station that continues to have problems, could we find out where the nearest one is for sure?
Yeah, we do that quite frequently when we're asked to assist them in getting right testing configuration. That's one of the first things I'll look at is where they're at in relation to an ADSB receiver. And you can see there's quite a few in the area, and even some of them that aren't close are being seen. We've had several up in Ohio, and I know of one up in Washington State that were well over 25 miles from the nearest ADSB receiver. But when you look at the actual location of the receiver, they're on a mountaintop on top of a tall tower, so they have a lot of visibility from that location. They don't necessarily have to be right on top of you.
Okay, so some facilities just have more visibility.
Correct.
Okay. And this is just a slide that shows the closer you are to a ground station, the higher the chance is that you're going to be detected and rebroadcast. Sometimes work unrelated to transponder testing is being done, but the transponder is turned on. Maybe weight off wheels is being simulated. It could be a contributing factor. Anytime you simulate altitude or weight off wheels, transponders on, maybe you're conducting other types of tests, you can cause the false targets. Could also be aircraft defects, maybe inadequate coaxial cable shielding. If a piece of equipment was installed by an STC and the STC calls for the double shielded RG400 coaxial cable, and the installer just left the old RG58 in there that was running the old transponder, this could create a problem. So this is one of the things that should be investigated. Make sure that correct coax cable is installed. Sometimes the antenna style, size, or design doesn't allow a good attenuator placement, as Carrie was discussing. It can be a challenge with the different styles and shapes and sizes of these antennas. Aircraft fuselage type, composite versus aluminum. Carrie, do you want to expand on that?
I think this was some information that we had in our white paper that we had written up, and it was brought to our attention by an engineer that a composite versus aluminum aircraft, which would provide some additional shielding, and you may get a better seal with your coupler. So it's possible. I think this is not as prevalent or likely of a situation.
Could be a contributing factor.
It could be.
So let's review some best practices to eliminate false targets when you're doing ground testing. Follow the aircraft manufacturer and test set procedures. And request the pub change if the procedure is lacking. And we have had facilities find that the aircraft maintenance manual just was not adequate, didn't even, just didn't have adequate procedures. Review your in-house procedures if you're a repair station or a Part 135 air carrier. You should turn transponders off if you're testing other systems. Verify that you have the proper test equipment with the couplers and attenuators. As we discussed, some of the equipment is just not compatible with the new attenuators. And yes, facilities might have to
I think we lost you, Gary.
Did we lose everybody?
I can still hear you, whoever that was.
Yeah, I'm still good. We just lost Gary.
Yeah, we lost Gary. Okay.
Marcus, do you happen to know if Gary was the only organizer for the webinar?
I think
Ryan Newman, I'm one of the organizers, but I am not an avionics guy, so I am not qualified to speak on the subject matter.
Ryan, can you run the screen?
Yeah, if you can advance the slides, Ryan, we'll take it from there.
Yes.
Yeah, let me see if I can. I don't think I can because I think Gary was doing it from his computer.
There may be a way where you can take control of the controls from the organizer privileges on the control panel.
Yeah.
So if you can find that there's a presentation pane. Yeah, well,
Yeah.
something changed. You did something there. Can you go to
shows-
slide?
Yeah, that just shows you my screen. So if I take charge, I can't take charge of his visual though.
Okay, I think I'm back.
Okay, Gary, you need to take the
Yeah,
screen.
I'm trying to find the. Okay, can you hear me, Ryan?
Yeah, we can hear you, but you need to take the screen back.
Okay.
Under sharing, click on the change presenter and click on yourself.
Okay.
There you go. And you
Yeah,
were on slide 37 when we lost you.
Okay. Sorry about that. Just lost the connection. So we were talking about best practices, verifying proper test equipment, making sure that your equipment is compatible with the attenuators. Obtain the attenuators and the RF blankets. Make sure that the technicians clean the surfaces of the fuselage. Make sure the antenna coupler is in good condition, especially the gaskets. Inspect test equipment cabling. Clean the antenna of oil and grease. And if you're not testing the transponders, turn them off. If possible, aircraft with redundant systems shut off the untested system, or you can use additional couplers on the untested antennas. Normally, transponders are wired so that only one unit is on at a time, but it's always one of the things you can check. Use the right test equipment and attenuators. Use the RF blankets. As you saw, they're not very expensive. And this was in the Viavi white paper, and this is a good practice. You can actually do a preliminary check using the flat antenna of the IFR 6000 to check for RF leakage. And Carrie, are you still on board with us?
Yes, I am.
You probably have this procedure in your actual operations manual for that test equipment.
Yes, it's in there. You know, once you have your RF couplers installed, you can do a quick check. You can just do an output power check of your transponder using the flat panel over the air antenna. You can even set your distance on the IFR 6000 further back than you are to give it a little bit of additional power, or MTL, and find out if the aircraft will respond to your interrogations. So if the aircraft is responding to your interrogations, then you do have some RF leakage with those couplers. Typically, if you have everything set really well, you probably won't hear anything with the 6000. But one other thing I'd like to mention, I don't believe it's in here, is there's a lot of shops out there that are using Flight Aware, and that seems to work really well. They do a ground, I believe they just do a ground elevation test, and if they're not being picked up on Flight Aware, then they know they have a good RF seal.
Oh, interesting.
Yeah, I was at a shop about a month ago, and they turned on Flight Aware. They have all their tail numbers all programmed into Flight Aware, so then that way, whenever they do get picked up by a ground station, they get notification right away. So when they're out there in the hangar and they're doing a field elevation test, if they're picked up, then they know that they need to do a better job of isolating or attenuating the signal.
All right. Another best practice, make sure you train your technicians. Regulations require training your technicians on new equipment. For example, a 10 or more air carrier under 135 is required to have a maintenance training program. And Part 145 repair stations have to have an FAA approved program. So now I'm going to launch the poll to ask a question. And then we will allow people to the poll should be going out.
Yeah, I
And-
clicked on it for you, Gary.
Okay. I was like, wow, that. Okay, so if you want to take a minute and answer that question, who is authorized to perform a transponder test under 91.413? And there's your selections: a properly rated Part 145 repair station, the holder of a camp under Part 121 or 135, an A&P mechanic, or both A and B. So we've got 77% have voted.
All right, I'm gonna shut her down in 5, 4, 3, 2, 1. All right, closing the poll with 81% voted.
Okay, looks like most people say that a properly rated 145 repair station can do it.
There's your poll results.
Okay, and we're going to get the answer here shortly. So according to the regulation, there's only 4 entities that can perform a transponder test, and they are a repair station with a Class 3 radio rating, repair station with a limited rating for the model of transponder and the test to be performed, a Part 121 or a Part 135 10 or more air carrier under their camp, and fourth, the manufacturer of the aircraft if they installed the transponder. So the correct answer is A and B, and we had 62% got the right answer, so very good. And another thing that's very interesting is according to 91401B, the altimeter system and altitude reporting tests and inspections required by 91.411 do not apply to Part 135 411A2, which is a 10 or more air carrier using a camp. Doesn't apply to Part 121, 129, or 91K. And the reason is camp airplanes are maintained in accordance with their continuous airworthiness maintenance program, which is accepted by the FAA and authorized through OPSPECs. Most camps, however, are based on the aircraft maintenance manual. So need to make sure we get the manuals correct. And the reason 91411 doesn't apply is another reason. If you compare the altitude error scales with the aircraft maintenance manual to Part 43 Appendix E, you'll notice that the scales are just not stringent enough to meet RVSM requirements. But 91413 applies to everyone. So we need to make sure that we're doing these tests correctly. And some good references are the SAFO, which I believe we had attached to this webinar, and AC 43-6D, which has a wealth of information about transponder testing. Also the aviation safety reporting system. I also want to ask the attendees if they are not on FAA safety.gov. I assume you are if you got the SPANS announcement, but I know some people were invited outside of that. Go on FAA safety.gov and create an account. You can work on your aircraft maintenance technician awards there. And this will be worth 1 hour of credit for that, this webinar. And there's just a wealth of information on that website. So now we will look and see if we have any questions.
All right, so far, Gary, there has been nothing put in the chat. Let me see if something appears here now that you've thrown it out for questions.
I'm looking under the questions tab. For some reason, it's hard for me to expand this window to where I can really read the question very well.
Well, I got someone who just sent you a thank you.
Wait a minute. Oh, okay. If I expand out the whole window. Okay. Okay, looks like the first question we have is, could the FAA issue an ADSB test transponder code? This code would tell other aircraft that this aircraft is on the ground doing a test. I'm going to leave that up to my panel of experts.
I'll take a stab at it, this is Charlie. That's a suggestion that's come up. I even thought of it in the beginning. And I guess the honest answer is it's not really practical, and we probably wouldn't want to do it anyway. First of all, there's security reasons and such that we would not want to have a code or a way that somebody could go invisible just by putting in a code, and their airplane would disappear from the ADSB system. The other side of that is that when we're talking about, for example, something as specific as TCAS resolutions and such, every unit would have to be redesigned to be able to recognize that code, realize that it's a test code, and not react to it. So that would just be logistically impossible to rely on a solution that would make us go back and have to change all existing equipment to function in a different way. So on the surface, it seems like, and as I said, it was one of my first thoughts, it seems like a very good suggestion, but logistically, it just can't be implemented.
All right,
Hey,
thank you, Charlie. I hope that answered your question, John.
Okay, I got a question here for you. Could the FAA issue an ADSB test transponder code? This code would tell other aircraft that this aircraft is on the ground doing a test.
Yeah, we just answered that one, Ryan.
Well, okay, so let me go to the next.
Next is, what is HMI? HMI is hazardously misleading information. And says what it said related to slide 15. Who do you contact to determine or find out or verify if the transponder signal is creating an HMI?
Gary, HMI, hazardously misleading information, is any time that the transponder is reporting a false position. In these examples, that would be when we've got the altitude system pumped up to an erroneous altitude. If the airplane is sitting on the ramp with its ADSB system on, transmitting its proper position and the altitude at the ramp that it's sitting on, that is not hazardously misleading information. That's accurate position information. So the hazardously misleading information occurs when we get in there and we change the static system and elevate the altitude of the aircraft to where it's now transmitting false information.
Okay, thanks, Charlie. Yeah, I'm sure they wanted more than what the acronym stands for, so thanks for that clarification. Okay, next is
Gary, this is Brent. Can I clarify something on that?
sure.
Just so everybody's aware, the ATC automation platforms, in other words, what controllers will see on their displays, on their data tag, when it comes to ADSB source information, the barometric altitude that your aircraft or the aircraft under test or the ADSB system under test, the barometric altitude being broadcast while that aircraft is in airborne mode, that is what gets through to the ATC displays or other ADSB in or traffic equipped aircraft. And therein lies the core issue with the whole problem here. And I think it's important to make sure we're all on a kind of on the same page with this, is that's really the whole deal here. If all we did was broadcast, like Charlie said, position information on the surface, none of this would really be a big deal, because it really doesn't affect anybody, you know, that's airborne in the corridors, especially around the major. It applies to the entire NAS, but it becomes even more critical in the congested areas around the major hubs around the country and the busier class Cs, et cetera, et cetera. So really the core issue has to do with the broadcast of the barometric altimeter data that gets processed on through the ground system and makes it onto ATC. And therefore we have the hazardous and misleading information that other aircraft and flight crews or other pilots or controllers may see that can, quite frankly, cause a panic. And MODIS transponders that coordinate with each other can issue traffic advisories, resolution advisories, et cetera, et cetera. And therein lies the core issue that we've been trying to get this message out. The only real way to do this is to get the RF out of the airspace or get it attenuated where it doesn't get to the ground infrastructure and get processed. So I just wanted to add that on there. Don't mean to be repetitive or anything like that. Just want to make sure that was clear in everybody's head that it's the barometric altitude portion of this that's really a problem. So
It almost makes me wonder if some kind of a software change could be developed to where if you don't have any ground speed, you don't include the mode, you know, the altitude information in the, I don't know, I'm just thinking out loud, I guess, if that could be pursued or looked into.
Well, there's some data in AC 43.6 that may provide some, I don't want to elaborate too much on it, but I'd recommend everybody read 43.6, currently in revision D. There's some other things there too that can help out with those folks that are in close proximity to an ADSB ground station, or radio as I call it. There's some things that can be helped there. So the problem always goes back to making changes to, you know, make a code, like Charlie said, can we change the software and all that? So ADSB avionics, as everybody knows, is pretty complicated, and a lot of different things that go into making it work. And so the MOPs that are identified in 91.227 to make all these things happen, those would have to be revised, and that's a task monumental. Doesn't even do that task justice. It's just too much to make it all go out. That'd impact everybody out there enormously, economically and time wise. It's just we've explored those options and they're just really not feasible, unfortunately.
Gary, I'll add to this. The message to the technicians and definitely to the management level that's overseeing training and such is that anytime there is a static test set connected to the aircraft and the aircraft static system is being told that the aircraft is at a different altitude than it's sitting at field elevation, they should be thinking about HMI. Because the problem is not just when somebody is sitting there testing data correspondence of an altitude encoder. They can be running totally unrelated to the transponder tests and not even be thinking about whether the transponder is turned on. And as soon as they start elevating the static system in the aircraft, they have the potential of transmitting the HMI. So training programs and such, I actually tell people the training program needs to be tied to the static test set, perhaps more importantly than just the transponder test set, because they could be sitting there without running a transponder test And if they've got the system up at a different altitude and the transponder turned on, they're on the air.
Right, good point, Charlie.
Yeah, I like to have the early on when we had some of the large 121s that were frequently showing up on our report. A couple of them put their heads together in as simple as putting a placard on the PDOT static test set, reminding them that they could be creating HMI. One of them just, we haven't seen them in over a year, just by that one placard on their test sets. So there you go.
That's an easy thing to do. Thank you. Okay, we'll go down through some more of these questions. Here's, not sure what's being asked here. It says, I get asked this sometimes, what about stubby transponder antenna attenuation? Not sure really what's being, what?
The probe antenna. Kerry, I think you've got good info on that, don't you?
We've tested the stub antennas before, and the 584 coupler that you've seen in the earlier slide will actually work on that. But again, it just depends on where that antenna is at and if you can actually get a seal on the aircraft. You know, if it's on a part of the aircraft where you can't get a good gasket seal, then we don't have a solution.
Okay, so they're talking about the little rod with the ball on the end, the little.
Yep, stub antenna.
Yep, little. Okay. Let's see, we've already had the question, could a dedicated transponder code for testing help? That's already been answered. How effective are the diversity boots for older test systems? They say IFR 401, which I think was a nav test set, or even current TIC 220.
I can't speak to the TIC couplers. The old diversity boots, they're not as effective as the couplers are. We have tested those, some of the older ones, and we do get right around 20 dB of attenuation. But with the newer couplers and a better seal, you can get, 30 or in excess of 30.
Gary, I have worked with several folks that use the TIC 220, and the TAP 200 coupler works pretty good for them.
Okay. What coupler? What's it called?
Their TAP 200 is their coupler.
Oh, okay. All right. The next question here is two questions. First, will leaving the transponder in standby mode during tests still generate a false target? I would probably say no to that one. How about you guys? If you're in standby.
If you're really in standby, no, it will not. However, I know of some installations where you might think you're in standby, but the transponder isn't.
Yeah, and didn't you mention that some aircraft automatically turn it on as like a fail safe, like you forgot to turn it on and you got ground speed and altitude or something?
That is correct.
And the second part of this question is there a map available for ADSB ground stations nationwide?
I'll take that one. In today's, in the context of today's environment, we have essentially been instructed to not provide a map of that information, a comprehensive document that will show you that stuff.
Mm-hmm.
But if you do have ground stations that have particular influence on your avionics shop or whoever you may be, then get a hold of us and we'd be glad to tell you where your particular ground stations are of concern to you. So generally speaking, no, we don't provide all those ground stations for security reasons primarily.
Okay. Thanks, Brent. Here's the next question. It's unfortunate when ADSB was being planned that the manufacturers of the equipment did not think of how to mitigate false targets testing on the ground. Something has to be done for operators that are located at a field that has an ADSB ground receiver. Can you publish a test code that we can use the transponders while we are testing? I think everybody likes that test code idea, I guess.
This is Charlie. This is Charlie. We answered the question about the test code, but
Right.
doing this for a year and a half. I point out, and I think Marcos will back me up, that we do not have a repair station that we have been talking with that still has a problem.
Okay, so you've been able to resolve all the problems, so that's good news.
That is correct.
As Kerry mentioned, you know, he mentioned in when he was talking about line of sight with a antennas across the field, and they solved that problem. So that may involve the blankets as well as the couplers and such, but
Right.
There is a solution.
All right. Next question is, most equipment allows booting of one antenna, but what can be done with Mode S equipped aircraft with upper and lower antenna?
Jerry, will you take that one?
Yep, go
Diversity?
ahead.
So for diversity systems, we have dual coupler kits. If you have an IFR 6000 or if a tick box, I believe they have a boot with them, so you can use the boot for one antenna and the coupler for the other. Again, the boot doesn't provide as much attenuation as a coupler does, but if you test it before you put your aircraft in the airborne condition up at any altitude, then you should be okay.
And if not, you might have to purchase 2 of the attenuators, correct, Gary?
That's an option, yes.
Okay. Next question, is there a real-time tracking system that we can log in through the web so we can see if the aircraft we are testing is painting a target? I think, Carrie, you had mentioned
FlightAware.
FlightAware.
Yep. I would recommend everyone go to their website. You can download an app and put it on your phone. It works really well. And what I suggest is you turn your transponder on at field elevation to see if you're picked up without any attenuation or any couplers or anything. Then put your couplers on and then see that the signal goes away, that you no longer see your aircraft on FlightAware.
All right. It's a good tool to use. Next question is, can we speak to...
And you can do that test at field elevation.
The FlightAware?
Yes.
Yeah. All right. The question is, can we speak to STC installations? The asker has left the presentation, but basically, as far as an STC installation, what I was talking about there was every STC has instructions for continued airworthiness. So those need to be followed. And if you find that they're not adequate to prevent false targets, then I would contact the STC holder and have them update their ICA. And the poll result was 10% selecting A and P. Recommend clearing that fog by clarifying or reiterating the correct answer. And I think we went through the 4 entities that are allowed to conduct the test. And an A and P, signing it off under their A and P is not one of them. And I believe that was, oh, there's couple more. How do I find out how close I am to an ADSB receiver? And I think that has kind of been answered with some of the other questions. If you continue to have interference or false target issues during testing, you will be notified. And in part of the investigation, you will find out if there is an ADSB receiver close by.
If you give me the city, Gary, if the requester gives me the city, I can tell you right now.
Okay. James Carter, if you're still here and you want to type in the city. Not, was that Marcus that was saying, or was that Brent?
That was Brent.
Brent?
That was Brent. But if anybody has a question about their location, my email is at the bottom of the screen. You can send an email to me and give me your location, airport wise, and I can tell you exactly where the nearest receiver is to your location.
All right. Thanks, Marcus. Next question is, zero ground speed could also be hovering rotorcraft. Unlikely, but possible. Okay, that's not a really question, but just pointing that out, I guess.
Okay, we see them on the report.
And I believe that was the last question. I hope we've answered all your questions appropriately. And if not, feel free to contact either myself or Marcus or the ADSB focus group. Brent, what was that email again for your group?
Oh, that email again is Marcus LeBay at, no, I'm kidding, Marcus. I'll spell it out, ADSB FOCUS TEAM at FAA.gov.
All right, thank you. I want to thank all the panelists that joined us tonight, and I want to thank everybody that logged in and participated and watched the webinar. Just, I hope you take it back to your people and your facilities and spread the word.
Hey, Gary, I have one more thing to add. This is Kerry Crawford from Viavi again. We will be at AEA International in Dallas, the international convention, the week of the 22nd, I believe, of June, just here in about 3 weeks. And we're going to talk about this subject also. So if there's anyone online here that's going to be at the AEA show, please come by and see us. And if you have any questions about this, we'll be glad to help.
All right, thanks, Gary. And if the panelists don't have anything further, I will end the webinar.
This is Brent. I just want to say, just one plug. I always thank everybody for the cooperation in this. My little spiel is that we all wear a safety hat on some level. And so for everybody out there that's in industry doing this, I truly appreciate everybody's cooperation and invested in the equipment. We know it's a little bit of a burden and taking this problem seriously. So for the interest of aviation safety, really, that's what it's about. So thank you for that. That's
yeah,
all
I'd like to get one fact in here. June of last year, when we started this, we had 586 events in June, with 438 being actual tests. And our best month so far was February of this year. We had 200 events with 110 being actual tests. So hopefully we can get these even lower, but that's a drastic decrease with everybody's help, from 438 tests a year ago to 110. Thank you.
All right, very good, Marcus. Thank you. Okay, if there's nothing else, appreciate everybody's participation. Thank you very much. Have a good night.